In this lesson, we're going to combine functions and compose functions, right? This is lesson 2.6. Okay, so the first half of this lesson is going to be on combining functions, all right? And really the only new thing with combining functions is the notation, right? If we ask you a question like find f plus g of x, that's really the exact same thing as taking whatever f of x is and adding it with g of x, right? Same thing with f minus g of x, right? If I see a minus in between f and g, I'm just taking f and subtracting g from it, right? Multiplying, you might see fg of x, right? And you just take your two functions, multiplying them together. With dividing, you just throw one right on top of the other, and then you do have a domain restriction, right? If you guys remember from beginning of chapter 1, right? With fractions, you cannot have 0 on the bottom, so you do need to specify that domain restriction. All right, so here we're just given two functions, right? F of x is 2x plus 1, g of x is x squared plus 2x minus 1, and we are asked to find different combinations of these functions, right? So number one is saying find f plus g of x. Really what that means is you're going to take f of x and you're going to add g of x. All right, so f of x is this right here, right? It's this 2x plus 1, so it's going to be a 2x plus 1, right? That's f of x, plus g of x is this right here, x squared plus 2x minus 1. All right, and this becomes a simple problem with polynomial operations, right? If you're just adding two polynomials, you can just drop the parentheses and combine like terms, right? Nothing combines with x squared, right? 2x plus 2x is going to get you a 4x, and 1 minus 1 cancel out. So we have that this x squared plus 4x is f plus g of x, all right? And then if we are asked to find f plus g of 2, all we have to do is I'm going to plug in 2 into what we just found for f plus g of x. So what that's going to leave you with is it's going to leave you with a 2 squared plus 4 times 2. All right, so it's going to get you a 4 plus 8, so 12. All right. Another way that you can get the same answer is you can say that this is the same as f of 2 plus g of 2, right? And then f of 2 is 2 times 2 plus 1, which is 4 plus 1, and 4 plus 1 is 5, right? So then this is going to equal 5, and then g of 2 is going to get you 2 squared plus 2 times 2 minus 1, which is 4 plus 4 minus 1, which is 8 minus 1, so 7. So we get g of 2 is 7, and then since our operation in between is a plus, I'm just going to add them. 5 plus 7 is 12. So you get the exact same answer doing it a different way, right? You can do it whichever way that you'd like. I will say if you already have this function, you should just plug it right in there, right? But let's say on a test or a quiz, I don't even ask you this at all, right? I only ask you to find this. Then you might not want to bother trying to find this first, right? You might just want to plug it into each of them individually and then just add them, all right? We can try the exact same thing with f minus g of x, right? I'm going to take my function f, which is 2x plus 1, and then I'm going to subtract g of x, which is x squared plus 2x minus 1. With the minus, you would treat it as if it was a negative 1, and you would distribute that to each term. Right, so again, just simple polynomial operations. So I get minus x squared minus 2x plus 1. And then combining like terms, it's going to get me a negative x squared. 2x minus 2x cancel out, and then 1 plus 1 gets you 2. So that means my answer here is negative x squared plus 2. And to find f minus g of 2, again, one way to do it is take that 2 and plug it directly into what we just found. All right, so this is going to get me a negative 2 squared plus 2, and this is a negative 4 plus 2, which is a negative 2. Right, and again, another thing that you could do, right, this is option number 2, is I can say that this is the same as f of 2 minus g of 2. F of 2 we previously found as 5, minus g of 2 we previously found as 7. So 5 minus 7 is going to get you a negative 2. We get the exact same answer. I'm writing both ways. That doesn't mean you have to do both ways, right? Do whatever works best for you, right? But that's it for that page. All right. Now, let's say we want to find f times g of x, right? Again, that just means I'm going to take f of x and I'm going to multiply it with g of x, right? So f of x in this case is x squared. And then I'm going to multiply that with x minus 3. All we have to do is distribute, right? When I distribute this, I end up with an x to the third minus 3x squared. That's all we had to do. All right, so you get something like that. Fg of 4, again, all you have to do is take 4, plug it into what we just found, right, into f times g. And so this is going to get me 4 to the third power minus 3 times 4 squared. All right, and 4 to the third power is 4 times 4 times 4, so it's 64, minus 3 times 4 squared is 16, and this is going to get me 64 minus 48, and 64 minus 48 is 16. So I get that fg of 4 is 16. Again, another way that we can do it is we can say that this is f of 4 times g of 4, right? And then f of 4 is 4 squared, so 16. So then I get 16 times g of 4 is 4 minus 1. I'm sorry, 4 minus 3, which is 1. So I get 16 times 1, which is 16. All right, and you can see even having this function already established, right, the work for that was a little bit longer than just doing 16 times 1, right? Maybe we had a little bit more work up here. But again, as you do these, you're going to decide what's better for you, right? Again, sometimes we won't even ask you to find this part of the problem, right? We might only ask for this. And in that case, you might just want to plug it into each separately and then multiply, right? But if we want this as well, then it would make sense to figure out what this is going to be and then plug it right in, right? So what we're going to do here now is divide, right? So we're going to find the combined function. With division, it's pretty simple. All we have to do is throw one right on top of the other, right? F over g of x is the same as f of x over g of x, right? And f of x in this case is x plus 2 over g of x in this case is x squared plus 5x plus 6, all right? The only thing we want to do here is make sure that we're simplifying this fraction fully, right? And to figure out if it's fully simplified, we need to make sure that the top and the bottom are fully factored, all right? So let's fully factor the top and the bottom, right? The top doesn't factor any further, but the bottom factors of 6 that add to 5 are a 3 and a 2. So I get x plus 3, x plus 2, all right? And then you notice x plus 2 cancels out. So really, this is going to leave you with 1 over x plus 3, right? You do want to state some restriction on your domain, right? Just because we cannot have the bottom of a fraction be 0, right? So I have that my denominator, this cannot equal 0, cannot equal 0, cannot equal 0. Even though you canceled it out, it was there to begin with, right? So really what I would do here is I would have to say that x cannot be, in this case, right? So I have that x can't be negative 3, right? Because when you set this equal to 0, you get negative 3. And I get that x can't equal negative 2. Meaning that these are two values that you are not allowed to plug into your function, right? If you plug them in, at some point you will get an undefined value. So I'm just going to say, as a little extra right here, I'm going to say that x can't equal negative 3 or negative 2. So that's really part of your answer, right? You need to actually say that you can't have these values in the bottom, all right? Let's try the same thing with the next one, right? So I'm going to say g over f of x is x plus 2, right? Because g of x is x plus 2, and then f of x, oh wait, hang on, I did that backwards. My bad, right? G of x is x squared plus 5x plus 6 over, and then x plus 2. All right. And now we want to do the same thing, right? We want to make sure that this is fully simplified. This becomes x plus 3 times x plus 2 over x plus 2. And then you see that x plus 2 cancels out. So our fully simplified expression is just going to be x plus 3. All right. And again, you want to state a restriction on your domain, right? I know that the bottom cannot equal 0. All right. This cannot equal 0. And the value of x that makes it equal to 0, if we subtract 2 on both sides, I get x can't equal negative 2, right? So I get x plus 3, but x can't equal negative 2, right? So that's also part of your answer, all right? It's the only thing that maybe make these sort of problems tricky, all right? And also not always are these going to factor and cancel out. Sometimes you literally just have one function right on top of the other with no additional restrictions, right? Well, the only restriction is what's going to make the bottom equal to 0, but no other work besides that. All right. This is the part that's maybe a little new to you guys, and it's composite functions, right? So this f with this little circle just means that you're plugging the entire function g into f of x, right? And same thing with g with this little circle of f of x. That means you're going to plug f into g, all right? I'll show you what that means in the next 2 slides. All right, so something like this. I have f of x is x plus 2, and then I have g of x is 4 minus x squared, all right? And f composed with g of x, right? So you can say f composed with g, or you can say f of g of x, right? What this means is you're going to plug g of x into f of x. So this looks something like this, f of g of x, all right? So just to kind of get you guys familiar with this idea, right? If I asked you guys to find f of 1, all right, how would you do that? Well, you see that there's an x right here. You would simply just plug in a 1 everywhere that you see an x. So 1 plus 2, so 3. And then you can imagine that that's going to be the case with any number, right? F of 5 is going to be a 5 plus 2, which is 7. Now, let's say I plug in something else. Let's say I plug in f of t. That's going to get me t plus 2, right? And that's all I can do with that, right? So now in this case, I want to plug in f of g of x, right? Well, what's that going to get you? Well, that's going to get you g of x plus 2, right? In this case, g of x is our entire input. So I'm plugging all of g of x in for that x right there. But we know what g of x is. It's 4 minus x squared. So this is going to get me 4 minus x squared plus 2. And then you just want to combine like terms, and this is going to get me a negative x squared plus 6. Right? And then that's your answer. All right, let's try the exact same thing the other way around. Right? Again, to get you guys familiar with the idea, how would we find g of 1? Right? All you do is plug in 1 wherever you see that x. Right? So this is a 4 minus 1 squared, which is 4 minus 1, so 3. If I had g of t, right, it's going to be 4 minus t squared, right? Nothing more I can do with that. And so this g of f of x means it's g with f of x plugged into it. So that means I'm going to take this function f of x and I'm going to plug that where I see the x in g of x. All right, so then this is really going to get you 4 minus f of x squared, right? But f of x, we know that that's x plus 2. So this is going to get me 4 minus x plus 2 squared. And then you simplify this as much as you can. And this is going to get you 4 minus x plus 2 times x plus 2. Write it twice, FOIL it. When you go to FOIL it, that's going to get you a 4 minus x squared plus 4x plus 4. All right, distribute that negative, and that's going to get you a 4 minus x squared minus 4x minus 4, and then the 4's cancel out. And so we're left with a negative x squared minus 4x. All right. So some of these require a little bit more work than others. but that's in general the idea, right? You're taking one function and you're plugging that into the other one, all right? Now, if I want to find g of f of negative 2, again, there are two ways to do this. We already know what g of f is, right? And it's this function right here. So what we can do, one option, is I can take negative 2 and plug it right in there. And that's going to get me a negative 2 squared minus 4 times negative 2. And so that's going to get me a negative 4 plus 8, which is a positive 4. Another thing that I can do, right, so 4 is my answer for this, but another thing that I can do is I can say that this is g of f of negative 2, meaning I can find what f of negative 2 is first and then plug that into g, right? And if I find f of negative 2, that's negative 2 plus 2, which is 0. And so now from here, that's going to replace f of 2. So really I want to find g of 0, right? So g of f of negative 2 is g of 0, right? This is what we're replacing. And then g of 0, when I plug in 0, it's going to get me a 4 minus 0 squared, which is 4. Which, again, if we only asked you for this and not the actual function, this is probably a little bit easier to do than first finding the actual function, right? You can see that we did kind of a little bit of work over here. So requires a little bit less work than if you were to find the function first and then plug it into the function. So it's good to know both ways. All right, let's try one more page of examples. Again, f of g of x, that just means I'm going to plug g of x into f of x, right? So f is first, g is second. So that means g of x, this is going to go into that x that I see in f of x. So this is going to get me 2 of g of x plus 5, all right? But g of x is 4x squared plus 1. So this is going to get me 2 times 4x squared plus 1 plus 5. Distribute and then combine like terms. So I get 8x squared plus 2 plus 5. And so this is going to get me an 8x squared plus 7. All right. I can do the same thing with number 13. All right. Take f of x, right? So this is, again, g composed with f of x means g of f of x. All right, and so what does that mean? That means I'm going to take f of x and I'm going to plug that to the x that I see in g of x. So this is going to get me 4 times f of x squared plus 1. But f of x is 2x plus 5. So this is going to get me a 4 times 2x plus 5 squared plus 1. And this is going to get me a 4 times 2x plus 5 times 2x plus 5. Right? I would do the exponent first for order of operations, right? So FOIL this, and then when you FOIL this, right, 2x times 2x is 4x squared, 2x times 5 is 10x, 5 times 2x is another 10x, so that's going to get you a 20x, and then 5 times 5 is 25, so plus 25, and then I still have that plus 1. Multiplication is next. I can distribute, and this is going to get me a 16x squared plus 80x plus 100 plus 1. And then lastly, combine like terms, which is just going to be 101. So it's going to be a 16x squared plus 80x plus 101. All right? And that's what we would do for that one. All right, to find f of g of 4, all we have to do is plug in 4 into that x that we found in f of g of x. Again, I'll show both ways. You don't have to do both ways. All right, so the first way is we already have this function. I'm just going to plug in a 4. So this is going to get me an 8 times 4 squared plus 7. So this is going to get me an 8 times 16 plus 7, right? You can do 16 times 8 off to the side if you need to. All right, so this is going to get you 128. So then I get 128 plus 7, and that's going to get you a 135, all right? The other way that you can do it is you can find f of g of 4. All right, so let me split that up, right? is you can find f of g of 4, right? So meaning first, I want to find g of 4 and then plug that into f, right? So first, finding g of 4 is it's going to be 4 times 4 squared plus 1. So it's going to be 4 times 16 plus 1. So 64 plus 1, which is 65. And then that is going to go in there. So we want to find f of 65 now, right? Which that's going to get me 2 times 65 plus 5, which is 130 plus 5, which is 135. All right, so we get the same answer both ways. Again, you can pick whatever works best for you. All right, but that's in general the process.